In this reaction, I'm going to draw the hydrohalogenation of 4-methyl cis-2-pentene. Now, first of all, I want to make sure that everybody knows what hydrohalogenation is. That's the addition of HCl or HBr. So in this case, I'm going to add HCl. So we're going to add HCl to 4-methyl cis-2-pentene. Now, this is a cis double bond right here because the carbon chain comes in on the top, goes across the double bond, and goes out on the top. So it doesn't switch sides. Remember in the previous example, or in the example that I did with halogenation of the alkene, the carbon chain came in on the top and went out on the bottom. Here it goes out on the top. So it stays on the same side, so it's cis. We're adding HCl, and in the hydrohalogenation of the alkene, we do not need to have any sort of a catalyst. Now, when we add HCl, we have two places where our will go. We have this carbon and this carbon, because our double bond will be eliminated. Now, we have a choice to make. We can put a hydrogen here, the chlorine here. We can put the chlorine here and the hydrogen here. The way that we determine where it goes is by how many other carbons and hydrogens are on each of these. Now, for each of these, there's exactly one hydrogen here and one hydrogen here. So they're equal. When the double bond has equal substituents on it, meaning it's connected to one carbon and one hydrogen, we will get two products. So I'm going to draw, and so let me number these. 1, 2, 3, 4, 5. I'm going to draw it where the chlorine adds to carbon number 2 and where the chlorine adds to carbon number 3. Since in the product there will not be a double bond, I'm simply going to draw it in the traditional way that we would represent a 5-carbon chain, and that is as pentane. So we have 1, 2, 3, 4, 5, and we have our methyl group on number 4. In the first example, I'm going to show the chlorine adding to carbon number 2. So I will put a chlorine right here, and this would be called 2-chloro-4-methyl pentane. Okay. And that will be formed in about a 50% ratio. The other product will be when the chlorine adds to carbon number 3. That will also be a pentane-based molecule with a methyl group right there, and the chlorine will add to carbon number 3. So this would be called 3-chloro-2-methyl pentane. Notice that the numbering switches in this case because chlorine, whether I go from the left side or the right side, is always going to be number 3. And if we have the opportunity to make this one a smaller number, we will. So we'll call this number 2. In this case, chlorine needs to be number 2. And this product will also be made in a 50%. So it's 50-50 both of the products. Remember, the hydrogen goes on to the other carbon. So in the case of this molecule, the first product that I drew, we added a hydrogen right here, so there are 2 hydrogens there instead of just the one that was there at the beginning. And in the second molecule, the hydrogen got added here, but we don't need to show it because we've used the line bond structure.